Hey guys, so a day in the life of Miss Rogers. I will let you know what's happening today, which was for the last, hey Al, for the last week or so, our dishwasher has been broken. So my husband, Phil, is currently working on that. Thinks he's fixed it. Had to go on to the internet and look up what the code was, and it was blinking the auto light, which said it was either the hot water or the pressure. So anyway, he's fixed the pipes. Al got under there with him and worked on it a little bit. So anyway, that's what's happening now. There's my doggy. There's my hubby. All right. Stuff everywhere from underneath the sinks. All right. So that's it. And now we're going to work on parent transformations. So, not changing your parents, changing parent graphs. All right, give me a second, get this thing situated. Okay, so parent transformations. The stuff that I had assigned for today, the Khan Academy is going to be changed. So to one of them being, or no, both of them on Friday, and then the quiz being moved to Monday. So if you already started working on that, sorry, sometimes plans change. Just based on what we went through today in the virtual classroom, on Wednesday in the live classroom. All right, I enjoyed hearing from all of you, and I hope to see all of you again next week and to hear from all of you and maybe a little more, chiming in. I enjoyed it. All right, so let's talk about function transformation. All right, so if you start with a parent function and you move it around like we talked about in the part A of all of those, like what did it do? What happened? What changed? Then that's a transformation. Okay, makes sense. You start with parent and then you move it around, and then it's been transformed into a new graph. All right, so let's see. All right, so we okay, so let's say that I have this graph. Oh, so actually no, let's say in general, if I have inside the parent operator, okay, that's going to go opposite of the opposite / inverse, really, because opposite means negative, so really mean inverse, but lots of students think of that as opposite. So inverse operation. Okay, and then if it's outside the parent operator, and I'll explain what I mean by that, then you're going to do the same operation. Okay, so for example, if graph, okay, y equals, let's just start easy, x minus 1 squared plus 3. Okay? All right, you know how to do this just by graphing in vertex form. So we've done a parabola, the vertex, axis of symmetry, finding the y-intercepts, finding the zeros or x-intercepts. So we're not going to focus on that with transformations. We will put all of that together again and practice that with zeros and what is the difference between a zero and x-intercept like we talked about in the classroom. But right now we're just focusing on like what the picture does. Okay. All right. So we're going to start with the parent. Well, we know the parent, and then you can either make an XY chart or you can use shifting rules. I don't care, just as long as you get that full picture. So we know that this is going to look like a U. So I'm going to grab my other color because those are my thoughts. All right. So we know that it's going to be an upward U because this is positive. So it's going to be an upward U. Okay. And then I know that the vertex is 1, 3, because this is opposite of the inside. So that's all I mean. See, if it's inside the parent operator. So this is the parent operator. Okay, so this is inside. So +1. And this is outside. So +3. Okay. Oh, and then something up here, outside or inverse operations. This is, I hope you can squeeze this in, but this is going to be left, right, and this is going to be up, down. Okay, so +3 right, in other words, right? And then this is +1, so up. Okay, so if you think about where the parent is, back to my original color. So if you think about where the parent is, okay, so the parent is at 0, 0, 1, 1, and 2, 4 if you want to do those. 2, 1, 2, 3, 4. But those are going to be off the screen for the, off my graph area. Okay, so that's the parent. Okay. Then we're going to go right 3 and up 1. So we're going to take each one of these points and go right 3. So yeah, I think I can fit to go to 5. If you can't, that's okay. But all right, right 3. So 1, 2, 3, and up 1. Now take this point. 1, 2, 3, up 1. This one. 1, 2, 3, up 1. This one. 1, 2, I need more. Okay, so this point. 1, 2, 3, up 1. And then this point. 1, 2, 3, and up 1. And if it comes out looking funky, you did something wrong, because they got to make a U still, because we know their basic shape. I kind of missed that, dude. I'll just make it bigger. There we go. Okay, and then this one is y equals x minus 1 squared plus 3. Okay, I'm actually going to trace that in my other color just so that it's very obvious what changed. You don't have to, but I just had too much going on there. Okay? All right, so what happened to the parent function? Well, it moved right 3 and up 1. Okay, let's do a little more. Now, I will not be giving you double inside moves. That's a pre-calculus thing. You only have one inside move. You can have double outside moves, though. Okay? I might give it to you like as a challenge extra credit problem, but not as something you're expected to know in Algebra 2. Okay, let's do another one. Y equals 1/2 x minus 3. Oh no, we did a minus there, so let's change that to plus 3, absolute value, and then minus, I don't like to use very big numbers, minus 1, just because then we got to do a big screen, a big axes. Okay, so so now we've got to think about what happens. So first, this is inside, so it's a left-right, so it's left 3, because it's plus 3 and you do opposite of what you would think, or inverse operation, so minus 3 to the x's, right? Then outside you got to do order of operations. So this is first. Well, first I'm going to go this, right? Then step 2. Step 2, I'm going to do half of the height. So I'm going to half the height. See, because that's an up or down move, but it's a multiplication. So multiply means multiply by half. Okay. And then step 3, I'm going to go down 1. Okay. So these are, the outside stuff is easy. It's just the same as you see. So half it and then move it down 1. But these are, the order does matter for these two because they're both outside moves. So follows order of operations. Multiplication before subtraction. Right? Okay. Okay, so now we're ready. We're going to be going down and left, so I'm going to need more this way than anywhere else. So I'm going to put my y-axis like here. And hope that's enough room. 1, 2, 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3, 4. Okay. So now first we draw a parent function. 0, 0, negative 1, negative 1, 1, 1, negative 2, 2, positive 2, 2. I don't know, you need to ask Daddy. If you can. Okay, and this is y equals absolute value of x. Okay, so just, you know, look back in your previous notes for that if you don't know how I got that. Or just kind of, I mean, what I do is I literally just think y equals absolute value of x, and then I just plug in points to the absolute value. But I have it kind of in my head that everything centers around the origin and its shape so that I know when I've got it. And I like to do like 3 points, maybe 4 points, okay? But as long as you're getting around that vertex, around its main part, all right, the part that you can see in the parent functions video, then you're good. Okay, all right, now I'm gonna grab my other color to graph my answer one. Okay, and this one up here is my answer one. Okay, all right, this is my helper one, which if I were doing this in pencil I would erase, but since I want it all in my notes, then I don't want to erase anything. So maybe I should have done this one dotted, but anyway, 20/20 hindsight. All right, so now I'm gonna go left 3. So I'm gonna start with this point. I just like to start with my leftmost point and then go through all of them to the right. Okay, so I'm gonna go left 3. 1, 2, 3. Okay, left 3. Then I'm gonna half the height. This is the height. Okay, it's from the x-axis. Even if it was down here, it's just to the x-axis is the height. Okay, like this is the ground. So this is 2 tall, so now it's gonna be 1 tall. Okay, then I'm gonna go down 1. Okay, next one, left 3. 1, 2, 3. Half the height, well, it's 1 tall, so it's gonna be a half tall. And then down 1, well, to be down 1 means to go, well, I'm at a half, so now I gotta be negative a half. Okay, all right, left 3. 1, 2, 3. It has 0 height, so half of 0 is still 0, and then down 1. If they're not lining up as a perfect straight line V, then you know that you did something wrong, okay? Now here's where I would pause the video if I were you, and I would try the next 2 dots all on your own to see if you get them, okay? All right, so now this one, left 3. 1, 2, 3. And then it's 1 tall, so half that height, and then down 1, which, you know, rules of symmetry just say that obviously it's going to be here, and then this one's going to be here. But let's just check. Left 3. 1, 2, 3. Its height is 2, because I'm at y equals 2, so half of 2 is 1. And then subtract 1 from 1, and you get 0. So this And don't go through that y-axis unless you know where you go through it. Stop your arrow short so you don't, you know, because I'm picky about y-axis and x-axis. And, you know, most of you probably have me next year, so. All right, and then this, I'm going to label this as y equals 1/2 x plus 3 minus 1. And I'll just box it so that we know that this is the answer to the graph. All right, let's try one more. And this one, after I give it to you, I highly recommend that you pause the video and try it all by your little lonesome. Oh, and something else here. You can always check if this is right. First of all, you're at home, so you can check it via Desmos by plugging in this and see if you get this picture. All right? The other way you can check, though, is you can pick, plug, plot. So pick a point. Plug in, well, first of all, we can see this is the vertex. It works just like parabolas, right? -3, -1, -3, -1. There's the vertex, so I probably did it right. But check at one of these zeros. 1, 2, 3, 4, 5. Plug in -5 right here. Okay? If I plug in -5, okay. Oops, absolute value. -5 plus 3 minus 1. And I get, so I'm just taking this point right here, and I'm just seeing is -5, 0 true. Okay, so I plugged in -5, and then I get what? That's 1/2 of -2 minus 1, and then that's absolute value, so that's 2, so 1/2 of 2 minus 1, which is 1 minus 1, which is 0. Okay, so now you probably did it right then. Now we have symmetry around this and everything, but you can always just take a point and plug it in and see if you got it right. Okay. You also, like I said, do not ever have to use shifting rules. What I do is I kind of use the shifting rules for the vertex to help me find good points to plot, and then I'll plot a couple of points around the vertex by using pick, plug, plot method. Okay. All right. So let's do another one. But for this video, we're purely doing transformations. So I'm just trying to stay true to that. All right, 3 square root of x minus, let's do minus 2. And then outside of the square root, so I kind of like put a little thing here so I know that that's ending. And then plus 1. Okay. All right, so I would pause the video if I were you, graph the parent function, and then graph the new guy, and then unpause it and see if you get it right. All right, so here we go. So we're going to graph the parent function. Oh, well, actually, I like to write my steps first. So this is going to be, first, I'm going to do right 2. Second, I'm going to do triple the height, so 3 times the height. 3 times the height, right? So it's going to be 3 times taller. And then up 1. So that means I'm going to have to go pretty far up on the y-axis. Hopefully I planned this well enough. That 0 is kind of in my way, but whatever. All right. So let's go way down here. I need to go up to about 6. No, 7. But I don't need to go very far over. Right, 2, 4, 5, 6. I need to go over to 6 and up to 7. So I'm actually going to do every 2 now. Evie, what you doing? I thought you were going to Kennedy's.
My phone. I have to charge it.
Oh, you got to charge it.
Yeah.
What are you at?
12.
Oh, all right. You don't have too long then. Okay. So 0, 0, 1, 1, 4, 2. All right, and that's good. No, 30. That's the rule. Okay. And this is y equals the square root of x. And again, I mean, I don't expect you just to do that as quickly, but the square root of 0 is 0, the square root of 1 is 1, and the square root of 4 is 2. So that's how I got those. I just pick, plug, plot in my head. Okay, now I'm going to go right to multiply the height. Well, the height is 0, and then up 1. So there's my starting. And for this one, that's very important because it never goes left. Okay? All right, the next point, I'm going to go right to multiply the height by 3. Well, the height is 1, so now 1 times 3 is 3. And then, oops, I put a dot, but I'm not ready for that yet. And then up 1. There it is. Okay. All right, now I'm going to take this one, and I'm going to go right to, the height is 2, so 2 times 3 is 6. See how I did that in my head because I was expecting it, but I didn't expect you to do that. 1, 2, 3, 4, 5, 6. And then don't forget, up 1 more. So there's the shape. And this is y equals 3x minus 2 plus 1. Let's check. Okay. Let's pick a point. I want to pick this point. This point right here is what? 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7. So I'm checking if that is. So I'm going to plug it in. And then that's what? Square root of 4 plus 1, which is 3 times 2 plus 1, which is 7. So yeah, I probably did it right. Okay. Alrighty, that is transforming parents, which is shifting and shrinking and stretching outside inside stuff. Oh no, just kidding. You thought I was done. I forgot to do an inside multiplier. I've only done outside ones. So let's do an inside multiplier, which are very rare. All right. I don't even think they may or may not be on the Khan Academy. I think they do have like one question about it. But let's say that I have a function. So f of x is graphed. Okay. Graph f of 3x. Okay, so I'm not giving you a normal parent function that you would know. Instead, I'm giving you a graph and then asking you to change it. So let's say, so it's important for you to graph these points right where I graph them.
Mommy, the black wasn't here.
Okay, great.
I'm only at 16.
Who all's here?
On your place.
Dakota's going too? And you guys are all staying together?
I think so.
If you're not, then no, because Kennedy doesn't have a phone, so your phone has to be charged. Or is the backup battery charged? If that's charged, you can take that. Okay, so, okay, so let's see. That's the point 3, 2. Okay. And then, let's see. -2, 0. And then -3. Let's go up to 3. Okay. And then we're going to just connect them with straight lines. So this thing is going to be funky looking. It looks like I'm trying to do an absolute value, but then I don't. So, okay. All right, so this is f of x. All right, and then I want to graph f of 3x. Well, what does this mean? This means a third of the x distance. So that's like that's to the y-axis. Okay. Okay, baby. 6 feet. Okay. All right, so let's just start with this point. What is the x distance? Well, it's 1, 2, 3. So I'm going to do a third of 3, which is 1. Okay. Next one. What is this? It's 2. So a third of 2 is 2/3, right? That's how I did that. Okay, so 2/3, this is right there, basically. Okay, this has no x distance because x is 0, so it's still where it is. So I'm just gonna make that very red. All right. This distance is 1, so it's gonna be a third. This distance is 2, so it's gonna be 2/3. Oh, just kidding. I don't know why I was doing that one. That's not even a point. This distance is 1, so it's a third. So I get kind of discombobulated too. This distance is 1, 2, 3, so it's going to be 1. And that's it. So it goes here to here, and then to here, and then to here, and then to here. See? And it looks like the same shape. It's steepness and all that. It's just a third skinnier. Okay. Now, for reals, that's it. Bye, guys.